And this is to help us with the lab, to help me and to help you, because there is only one of me, and my availability is not infinite. Well, it is, but you'd have to know how to find me in the matrix to do that. So again, this page I made last night out of requests of many, many students over many years. And so we'll see how it goes. And with this, we're going to go beyond that study set that we just did. That study set was just looking at ions and really only looking at the main group, ions. And the question that was asked, they only make one ion. That's all we looked at. We only looked at the ion that they really make. So what's behind me on the board, which is hard to see to share and use the board at the same time, is that there's two groups. So if you have notes, if you don't have notes, you can do it on a piece of notebook paper. There are covalent. So write that way over on one side, and the other side we have ionic compounds. And this was a question that was on your homework, and it shows up at least once. I think it shows up 2 more times on study sets. Covalent is going to be 2 or more nonmetals. Now we're going to only be dealing with binary, so we're going to just see 2 nonmetals. But again, most of them have more than that. And ionic, we're going to see metal and nonmetal. They have a different way of naming. Since covalent is sharing electrons, whereas ionic is losing and gaining electrons, right? So the metals lose electron and become positive. The nonmetal gains electrons and becomes negative. So they're actually 2 very different ways of forming compounds, but the idea is still the same, that they were unstable. As soon as they're made, they're unstable, and they react, gain, lose, or share electrons. Now, they are not always in their preferred place. So, you know, kind of going back to the previous question, the reason we eat food, it's why you can eat crap food and still be alive, not healthy necessarily, but alive. All you need from your food is electrons. And that's what's going on in us, is we breathe the oxygen, and the oxygen wants the electrons from your food. And that desire for those electrons is what drives our body and gives our body energy and stuff. And that's the study of metabolism and biochemistry. All right, so because in covalent, this is actually a bond, is what covalent means. The type, it is we're going to make molecules. So when something has only covalent bonds, we call it a molecule. And because they are discrete units, we use counting prefixes. And I talk about this in that other video. I just couldn't figure out how to make notes for it. I watched it, and still, usually I just go up there and I just talk, and it actually works. The counting prefixes, the lab, everything I'm going through is in the lab. The first 3 pages of the lab, first 4 if you read the story, it is all these words. And if you try to sit there and read the lab right now, it's a lot of words. Even though it's only 3 pages, once you work on the lab, if you go back and read those pages, which I would encourage you to do, they will fill in a lot of gaps that may have been missing, or a lot of the questions that you have. And as you're working through the lab, it works you through each of the pages. And so there might be times where I might say to somebody, hey, go back and read that top of the first page, because that might help answer a question. But the example here, the easiest example would be CO2. You want to look at something, does it have a metal? If it has a metal, we're over here. If it doesn't have a metal, it's only nonmetals, then you're using count. You just tell me what's there. So we'd say carbon dioxide. So you're telling me, and that's what I mean by the counting prefixes, how many of something's there. The prefix mono, I have only ever seen mono used with oxygen. So monoxide, so carbon monoxide means one oxygen, and they delete it with everything else. So I avoid monos. We never show a mono with the first one. All right. On ionic, you never, ever in my class, because we're a chemistry class, use counting prefixes. And that is because they are a ratio, a positive to negative, to give you that overall neutral, which was with that last page, that second page of your study set. The ratio has to be overall neutral. So if you have something like MgCl2 and you call it magnesium dichloride, that is absolutely wrong. It's just magnesium and chloride. All right, so put a little star, that's important. Now with ionic, there's a hole here in the middle because I'm pretty sure I added it in the video. We will talk about acids. And it really, the lab walks you through, it starts with the covalent, the first 4 questions. They're really simple. We'll spend a lot more time with covalent the next 2 weeks. And so this lab is really mostly about the ionic. So ionic, you have your positive and you have your negative. So these are the metals, again, are positive, and there's 2 types. So this is a question a couple of you are asking me because you actually watched the video, which is really cool. You can have what I call the fixed charged, and that's what we had in your study set, and your quiz deals with these, that the 1As are always +1. We've renumbered our periodic tables now. And the alkali metals are the 1As, the 2As, the earth metals are always +2, and aluminum is +3. And then you have all the others, and they have a variable charge. And that is most of the periodic table. So variable charge is where we use the Roman numeral, and we'll do practice with these. And the Roman numeral is their charge. So, and we'll do practice, that's what that page is. And then I mention, and I'm gonna mention it because it drives me crazy. The correct rule is for these. So zinc, cadmium, silver, they actually truly now are over here. They are considered variable charge. They do get a Roman numeral. That is where the rules are. However, there's still so many people out there who don't want to change the rules. It's like other things that we figured out, that whole thing is wrong. It doesn't happen that way. But teachers are like, I don't want to change how I teach. I just want to keep it how it is. I don't want to have to make new notes. So that includes all the people I work with and all the tutors and half the stuff online. So half the things you'll find online will say they are fixed, and half of them will say, no, you just give them Roman numerals. They do get Roman numerals, but you will run into them sometimes where they leave off the Roman numerals. Yeah, we're going to go with the Roman numerals. I don't take points off, but you'll see me fix it for you. And I usually actually try to avoid them. When I first started teaching this list, there were 10 of them here. There were 10 of them that were considered fixed that you didn't put a Roman numeral with, including nickel that was on your study set. And it turns out they were wrong. They all had other charges. They just had a charge that was their most common charge. All right, with the negative ions, and again, when we do practice, we'll see this, they are always fixed. And so then you can get the monos or the polys. So the monos are the ones that were on your study set. That would be like Cl negative, that ends with IDE. And the polys are ClO3 negative. And these are the 8s that I talk about in the second video, and they take practice. They are the second page of your lab. So if you do your lab and you want me to look at it, I'm going to look at one page at a time because you have to get through the first page working with just simple ions first, and then we add in the polys, and then we add in the acids, and then we mix it all up and see if you can do it. So my suggestion for you, because I had considered making you guys a periodic table that would help you, because you can go to tutoring and they can give you this list of 200 polyatomics. And to me, seeing a list of 200 polyatomics, I would go, holy moly, that's a lot of polyatomics. There is a pattern. And if you understand the pattern, it actually makes it so much easier, and we can condense this down. I recommend that you modify your periodic table so it's like the wonderful one I used to always give out to my students in class, and was the one they had to use, and my students became brilliant. Their brains became bigger and better, because rather than trying to look up everything on Google, they actually did this, that in the lab it gives you just these 8 polyatomics, that you actually write them on a note card and put them on your periodic table. These first 5 I call the big 5. This is the Nick the Camel, because in there used to be a bonus points on like the quiz and the midterm if you knew them without the if you didn't need the cheat of the polyatomics. Now I can't do any of those bonus points because I can't control what you guys do. But if you have these in front of you, there is a pattern. These 3 are over here because they're a little bit, they're really common, but this is hydroxide. Ammonium has a positive, and that bicarbonate was named that way 200 years ago, actually over 200 years ago. They did not realize it wasn't 2 of them. They didn't know what it was, and it just means, the bi just means there's a hydrogen in front of the carbonate. And so that's what it is. It's as common as carbonate, and so it's right there, so you have it. So let's actually just go through the practice, and you can add things, or you can just, it's all there in the lab. So these first 3 don't, these first ones aren't dealing with the polyatomics yet. They're like the first page of your lab. And so the thing that we want to look at is with this very first one, we're going to write ions and put them together, because in the lab it has you do that. Is this first one is covalent. The last 2 pages of the lab actually have you fill in a column where you tell me if it's covalent, ionic, or acid, because they're named in different ways. So this, because it's covalent, you don't fill in anything for your cation, anion. So you can scribble it out, or you can just leave it blank. What I found in my other class is they had a hard time leaving it blank, so you can draw a beautiful picture of Tigger in there. These are really easy ones. They tell you what it is. It's silicon and 4 chlorines. They do not make ions. They're sharing electrons. So that's it. We just say SiCl4. It is a subscript, so make sure it's a lowercase number. All right. So the second one, it is metal, nonmetal, metal, nonmetal. So these are ionic, both of these. So we are going to write our ions, and that will help us put it together. So in the lab, it does make you write your ions to put it together. So potassium, that is just K+. And again, I recommend you write it above your chart. And what happens is you go through the lab, if you sincerely do it, you just start knowing these. And then fluoride, we find fluorine, and it's a -1. And again, you can show a +1 and -1. When you show the charges in this middle column, they are shown as superscripts. They show the charge and the number if it's more than 1. And our final answer does not have any charge in it. Cation is always first. And this is the 1-to-1 ratio. All right, lead. So I emphasized for the past 4 weeks, you need to know your elements. You can have a chart with the names on there, but if you're going to be spending this whole time trying to find each element, you're going to take like 5 times as long on this lab. So hopefully you're already familiar with your elements, so you know to just look for PB. In this 4, the Roman numeral is the charge of the lead. Lead, okay, let's talk about that. The variable ones are, as my thing says, anything that's not a 1A, 2A, or aluminum. So it's not just the Ds, it's any with D electrons. So even though I commented that when the Ds are full, they don't react, they allow weird things to happen just having D electrons. So everything in the middle, in the D block, has multiple charges, and all the metals after. The exception is aluminum. It's not actually an exception to what I just said. Aluminum is before we get to the Ds, as are the ones in the 2s. So they don't have D electrons. They only have one charge possible. But any of these guys over here, they're also considered, they do have multiple charges. So I will tell it to you somehow. If I give you the name, like here or here, I'm telling you what the charge is. So for this one, it's lead 4. Sulfur, we look at our handy dandy periodic table, and it's a -2. So if you have not printed a periodic table or made a big periodic table and posted it, you really want to do that. It costs like 10 cents to go and run off a copy, and you can do that at like FedEx or Home Office Depot and stuff. Now, I'm going to do this one wrong on purpose because a lot of you will do it wrong. That there's a number of you, and this is fine, that you go, well, I like that swapping thing she did. And so you get in the habit of always swapping. So you go, okay, this becomes the 2 and that becomes the 4. So the answer is not correct, because something I keep saying is it has to be the lowest whole number ratio. So they are fractions. 2,4 is a fraction that can be reduced. So we don't show the 2 gets reduced to a 1. We never show 1 subscripts. So it's PbS2. So there'd be nothing after the PB. So coming back to a question, the other way to think of it is this is giving up 4 electrons. So we need 2 sulfurs to gain 4 electrons. So it's just PbS2. It is a ratio. All right, now we're going to go the other way. So we just write our ions. Sodium we know is +1. Oxygen is -2. We know it's a +1 from the periodic table. And so we just say sodium. And then the O is oxide. So the ending of the second element always changes. The first element, we just say what it is. All right, on the next one, that is titanium. And it does get a Roman numeral. So what I'm trying to show you with these here is you want to figure out, do you need a Roman numeral or not? And again, the 1A's, 2A's, and aluminum, no number. Titanium or SN, tin is a sin, they will get a Roman numeral. So we're going to figure out the Roman numeral, and that is the magic we're going to do here in the middle. We get it from the anion. Chlorine is always a -1. There are 4 chlorines in this formula. So in this formula, titanium must be a +4. Titanium can be other numbers. When I was in school, we had to memorize all the numbers. And it's not that I'm nicer or chemists have just become nicer because we're getting backlashed everywhere. It is that there's more charges than they thought. So we used to think iron could only be 2 and 3. It turns out it can be 2, 3, 5, 6, 8. And they're finding, right, if you look for it, you'll find it. So we would put a Roman numeral 4. So Roman numerals, 5 is the victory sign, and 1 before 5 is 4. 4 is a large number. It's not very common. 5 and 6 are even bigger, and 8. They're really not common, but they do happen. On the lab, not very much. 2s, 3s, 1s are much more common. All right, we just get 2 4s in a row here, I just noticed. So the sulfur is a -2. So the tin must be a +4. because there's 2 -2s. So the number in the Roman numeral is not the subscript. It is the charge that has to balance out the anion. So this would be tin 4. And I just realized I just did 3 examples with a 4. I think very different when I'm having to sit down than when I'm active at the board. And so this is, I'm amused because I know how I teach. And there we go. So that's the first page of your lab, walks you through that. And then what happens is we run into these polyatomics. And they are on page 2 of your lab. Again, you can go to tutoring, you can go to all these places and get these lists that are much more involved. Having done this for years, decades, and having just done this with my other class, the students who followed my recommendation and just made the chart from what I gave them in the lab, they actually understood it much better because they could do the pattern and stuff. So if you see the ending of 8, you're looking at that list. The disadvantage they had is they kept flipping back and forth between their pages and the list. So that's why you might want to make a little note card eventually, so it's just right there on your periodic table. So we're going to write our ions. Magnesium is Mg+2. Phosphate, that 8 ending means with oxygen. So phosphorus and oxygen are PO4. These got named 8 for a reason that is beyond where we are yet. I'll get to it in a couple weeks, like a month. But 8 does not mean 3 oxygens. Nitrate, carbonate, and chlorate have 3 oxygens. Sulfate and phosphate have 4. Also, they're charges, so that's why you guys get a habit there. Chlorate, sulfate, and phosphate make sense because they go with their family charge. It's nitrate and carbonate that are the bizarre ones. The other thing that I mentioned in the second video when I talk about these briefly is for a high percentage of you, parentheses are going to be a game changer, or save it. The PO4 is a package. The phosphorus and oxygen are covalently hooked together, but when they combined, it didn't work out. They need 3 more electrons. So that's where the -3 comes from. So we have a 2 and a 3. So we're going to need 3 magnesiums. PO4, the 4 stays with the oxygen, and 2 phosphates. Now again, the polyatomics are challenging, but I wanted to show you some so when you get to that page, and I actually recommend that you do come to office hours and work on them, because trying to answer questions by email with this can become pretty tedious. And all right. So the Roman numeral is just telling us the iron has a 3, and then sulfate. So we just look at our lists of polyatomics, and sulfate is SO4 with a -2. So we have that 3-2 thing again. Again, it can be really nice to show parentheses. The 4 is part of the packet. We have a sulfur and 4 oxygens together, covalently linked, but they are not considered covalent. They are ionic because it didn't work out. They need 2 more electrons. And they're going to get it from the iron in a 2-to-3 ratio. So we need 2 irons for every 3 sulfates. All right, so the next one is the ites. Ite just means -1 oxygen from the 8s. So you have the 8s there. You would look up chlorate, ClO3, and you take away an oxygen. So it's ClO2. Charge is still the same. You don't have to do the parentheses. Well, you have to on these 2, but it really does help some. Chromium is Cr. Again, if you didn't learn your elements, at least becoming familiar, you're going to in the next week because this lab pretty much forces that point. So this 3 again goes with the chromium. I like to underline the endings because they tell me what I'm doing with these. These top 6 were all ides because they're not the polyatomic. And then we just combine it. We need 1 chromium and 3 chlorides. The polyatomics are challenging. The second page of the lab is probably the most challenging because it's a learning page. So you want to do the first page first, which is these first 6, so you get the idea of combining them. Your study set and quiz were just so we have the idea of what ions are, how they form. So back to the really nice questions somebody asked me about, do all the elements have 1 ion? We can see that a lot of them have multiple ones, and you're given the information of what it is there. As far as this lab and oxygen, because you happen to pick oxygen, it is going to be always O negative 2 as the ion. All right, so now we're going the other way. So we have Mn and we have NO3. Inside the parentheses, NO3 is a negative 1. So that is nitrate, because it's NO3. We want to check, so 3 is, yep, we're good. It's nitrate. And we look, there's 2 of these. They're both a negative 1, so that must mean the Mn is a plus 2. Now, a lot of students in my other class, one of 2 things happens with this quick lecture I'm doing. Either you're like, you made it seem so easy and I just left and went to do it on my own 2 days later and I had no idea what I was doing. You would hope your teacher knows what she's doing so I can make it seem somewhat easy. The other thing is some students were just like, I'm lost. I don't know what to do. I'm totally lost. So please don't come to me and tell me that. Tell me what you can do. Show me that you've done something. Yeah. And so say, okay, I understand. I get the idea that potassium has a plus 1. The lab builds on itself to help you get the confidence. All right, Mn is manganese. And it might also be a lab that is really good for you because it's a humbling experience that you need to spend time. This is chemistry. Chemistry has a reputation, it does. Nobody ever says chemistry is easy. Everything is easy if you spend the time to work on it. There is a clear pattern. This is much easier than the English language, which you all speak beautifully, because it has clear rules. All right, this number is the charge of the manganese. The other thing I'm going to ask, if when you come to office hours, if you have done a page and you want to check, because there's so much going on the page, you're going to have to take a picture and possibly email it to me. I'll be in my other room where I'll have 2 computers. So I'll be on Zoom on 1 computer or sharing the screen where we can look at it. Yeah, and we'll figure that out. All right, lithium. So something that can help you with the polyatomics in this way is to put a parentheses around it. So technically when there's only one of the polyatomic, there's no parentheses, but for a lot of students, it helps them to put it there. So we pull out lithium. We know it's plus 1 because you're going to have a periodic table sitting in front of you. And then we have BrO4, and it's going to have a negative 1. All right, so you look at the list that I told you and you're like, it's not on there. She's already lied to me and she's still even right there dressed as Tigger. I do talk about this on the second page of the lab. There's the family rule. I didn't talk about it in the video I made because there's so much information. But chlorine, bromine, and iodine are all in the same family because families behave the same. And so chlorate, bromate, and iodate all make the same type of polyatomic. If you know one of them, you know all 3. But a lot of students still need to have it there physically in front of them to look at it. So chlorate, bromate, so you can write that next to chlorate, bromate, and iodate. They're all going to be a negative 1. They're all going to have 3 oxygens. It's like, okay, and then you look at this and you go, she just told me it's BrO3. She must have made a typo. I did not. So don't change my numbers. This is that chart that's on page 2 that I talked about in the other video. So if you didn't watch the other video, you can stay and do like the first page of the lab. But then I would recommend you might want to watch the video and then come back later, unless some people pick this up really fast, that there is a chart where you gain and lose oxygens. We can just write it over here, and it's in the lab. And so when you lose an oxygen, we have this place where we start. So this is the common. It is not that you start with 3, it's that you start with whatever those ones we start with. And then you can take away an oxygen, you can add an oxygen. And so if you add an oxygen, you are now purr, like a cat purrs, right? Cats have paws, purring if you take pause in your day and pet them. So purr is short for hyper because we're above the normal number. So this is lithium perbromate. So perchlorate would be ClO4, periodate would be 1 more than where we start. I'm going to finish this chart. You can take this is the common, and the -1 are the most common. You can also go lose 2 oxygens from where you started, and then you say hypo and ITE, so hypochlorite, and it talks about that on the second page. All right, we have copper, we have SO3. We want to look at our chart. Copper, we don't know its charge. It's in the middle. But SO3 is going to be just like SO4. It's going to have the same charge, -2, but we lost an oxygen, so it's going to be sulfite. It's a -2. Adding parentheses can really be helpful. You only have 1 sulfite here. So those coppers are +1. Biggest mistake is students who see the 2 and 3 and they assume the copper's a 3. The 3 is just how many oxygens, it's not how many sulfites. So the name of this would be copper 1. We do not show subscripts of 1. We do show the Roman numeral of 1 when it happens. Lithium did not get a Roman numeral. Why?
Because it's a fixed charge. It's on 1A.
Yeah, so my other class, I'm like determined I'm gonna get everybody a bonus point in a class. Christian's got a phenomenal grade in this class, but actually got up to 12 people getting an answer. So you're only allowed to answer once in the class for a bonus point. So somebody else can try and participate. All right, I threw this one in here, NH4, it stays together. These are all binary. You're not going to get these crazy names. You're not going to say nitrogen tetrahydride chloride. There's no 3 words going on here. You have to find your 2 pieces. So they're binary. So adding the parentheses, we have NH4, and NH4 is one of the ones on my list, my much shorter list. So NH4 is ammonium. NH3 is not an ion, but that is ammonia. That's the gas that you smell when people have smelling salts. It is ammonium, ink sulfide. It might be ammonium chloride. The Cl is not a polyatomic, so the ending is IDE. No Roman numerals, it's just ammonium and chloride. All right, and then 14 is special. If you start trying to do ions, so I'm going to do this wrong. You're like, okay, I got this. Sc is a -2, O is a -2. What's going on? They're both negative. This is covalent. No ions. So you're going to leave this blank, or you can put an X through it. So no cation, no anion, no ions. This is where you just tell me what it is. Selenium and then dioxide. All right, and then we get to acids. So students always tell me they don't like the acids. They're so hard. They're so complicated. This is such a fun week for me because everybody's had midterms and multiple classes and everybody, you know, it's Halloween. So you do get a bonus point, not only for participating like Christian did, also, you know, if you dress up when you come to office hours and make your teacher smile, and just allow your inner child to play, because that's all there really is. All right, it is an acid because we see hydrogen. Now, common for you about acids, they are molecules. They are a special type of molecule that we get into in 2 weeks. Hydrogen is a nonmetal. So this is a covalent bond. This is not ions. However, in this nomenclature game that we are playing this week, it is easier to think about it as ions. It is not ions because ions truly have already given up, gained, and lost electrons. These are sharing in the compound, and until you place it in the water and the water pulls the hydrogen off as the proton, right? And then you're left with the carbonate with the -2. It cannot, the carbonate cannot get the charge without the water there. All right, so this would be the acids. The trick with the acids, the 3rd page of the lab talks about them. And again, if you have 8, it becomes ic, and then acid. And if the ending used to be ite, then it becomes OUS, an acid. So acids are icky and they burn us. I had a student and that's how he would remember that. So you look at CO3, you find it on your chart, it is carbonate. So now it becomes carbonic. Your teacher can spell. All right, let's try again. Do the lab with pencil so you don't have all these scribbles like your teacher does. And if you have not bought an eraser, go buy a good eraser because you're going to use it in this lab, you're going to use it next week, and you're going to use it the week after even more. We use it more each week. And so somebody told me it should be on the syllabus, a requirement that you have to have an eraser. All right, so for here, hydrogen. So for the middle boxes here, with my other class, some of them actually crossed these out because they wanted to emphasize that acids are molecules, and I'm fine with that. We don't say the word hydrogen, we say the word acid, but when we write the compound, we show the hydrogen first. And then chloric, ic was chlorate. So we put ClO3 and we just combine it. And that's the idea. It's going to take a little bit of practice and stuff. That's all I got. Is there any questions with that? So you can also, back here, we didn't quite finish, right? The polyatomics can be 8 or ite. The acids are hydrogen plus nonmetal. So they are covalent, but you can think of them as ionic, even though they are covalent. So if I ask the question, are they molecules or ionic compounds? They are truly molecules. And the trick there is just the 8s become ic acid. And the ites become OUS. So you can make, it talks about all of this in the lab, but having, this is kind of a guideline. I was trying to make a chart for you, and I was like, my chart, I couldn't figure out how to make it. There's actually, you can make a flow chart of your own to help you understand it. So with that, I recommend that you work on the lab. I recommend you stay and work on it. I will actually have the Zoom link open until 2 o'clock today. And then I have an office hour tonight. Thursday nights, I actually start. So this one today, I'll be on here until 2 p.m. So you can sign on, off, and come back on. And then There is a link. The evening one I'll be on from 5 to 7. So there were some people who had conflicts after 6, and so I'm starting those at 5. If somebody wants, on Friday, I am on from 4 to 6. That's a different link. And so if you want to be on tomorrow and it's not there because I forget to put it on there for you, just send me an email and I'll send you the invite. And then Saturday morning, I am on from 10 until noon. Again, if you come Saturday, I'm in another class and it's the link to their class and I just stay on it. So if you get there, just stay in the waiting room. Any of these times, just be patient because sometimes I'm helping somebody and I don't let you on. Yeah. And the other quick comment is if you have an iPhone and there's been issues, I've emailed you, which is more than one of you. There actually was an update to the iPhone app in the past month. And so you either have to update it or you have to delete it and re-add it because there was definite communication issues. And so, all right, don't wait till Tuesday to do this lab. You can sign off. I'm going to stop.